Hey guys, Connor, you're watching the JavaScript Mastery series, and in this video we are going to be covering objects. We're not going to be deep diving into objects, we're going to be looking into objects just enough so that you can use them confidently and get started and actually use them when you're programming effectively. Now the thing with objects is they can get tricky. A lot of the JavaScript programming languages focuses around objects, and we can go really deep into them, but we're not trying to master JavaScript in the Blue Belt series. We're just trying to get ourselves enough JavaScript knowledge so that we can begin using it effectively and also know what we need to know to be effective entry-level, graduate, junior developers. So not going to dive into things like inheritance, the prototype object. Not going to go into detail property descriptors, proxies. Not looking at object.freeze or object.seal. A lot of that stuff we're just gonna park it up here, and we're gonna wait until we get onto a more advanced belt before we cover those advanced topics. And instead, we're just going to learn enough objects so that we can use them and so that we can actually be productive and have enough knowledge of objects to just contribute to a code base that would be expected of a junior level engineer. Now, it can be frustrating and you might want to know everything in one go, but this is a career, not a sprint. We don't need to master objects in the next 10 minutes. So there's no point deep diving into a bunch of stuff that you're not going to retain and you're just going to forget. So let's just focus on the stuff that you can retain, that you can use right now, that you can put to practice, and the stuff that's actually going to come up in job interviews for junior level engineers. So we'll start off just by talking about what are objects, why do we use them, how do objects improve our code, and how do they actually make us better software engineers. Then we're just going to take a look at the different ways we can create an object. Just focus on the one way that you need to know. We're then going to focus on how everything in JavaScript is actually an object. Wait, what? A string's an object? Yeah, kind of. Don't worry, we're going to dive into that. Then we're just going to look at the different ways we can access and mutate properties, how we can change properties because objects are mutable, what that means exactly. Then we will talk about some common object methods that you can use if you want to iterate over an object, look inside it, nothing crazy. And then we will wrap things up by discussing how we can extend and clone objects and why we would actually want to do this, and why cloning objects is important due to the fact they're reference types. If that doesn't make sense, don't worry, it will in a minute, just stay tuned. Now, what we will not be covering, we will not be talking about objects, prototypes, inheritance. We won't be talking about property descriptors, getters and setters, symbols as keys, deep cloning strategies, sealing objects up with freeze and seal. We're not going to be diving into the quirky behavior of the bind keyword. All of that stuff is for a more advanced belt. So let's just focus on the basics, the fundamentals for now. Put it into practice, build some confidence, and then we will master those more advanced, tricky parts once we rank up to the higher belts. So let's get started. Okay, so let's just have a little talk about objects. What are objects? Why do we use them? How do they improve our code base, and why is it they make us better software engineers? Now, objects are just a great way of bringing organization and structure to our code base by grouping lots of things that are related into a single unit. Think of it like this. Imagine on your desk, you've got loads of things scattered. You've got crayons, pencils, maybe you've got a sharpener, ruler, highlighters, and just imagine it scattered all over your desk. It's going to be a mess. It's going to be chaotic. Now imagine you're trying to lend somebody one of these items, right? You're going to have to hand over all of the individual items one by one. It's going to be messy, chaotic, and it's also going to be a lot to keep track of. But if we was just to toss all of these items into a single pencil case, then now you've got a nice, neat, self-contained package to hold all of these things together. And that's essentially all objects do in our code. We group things together under a single unit that helps keep things more organized and more structured. It makes things easier to manage, easier to read, makes things easier to pass around. You can just pass over the single pencil case. Let's say you're sending data to an API, or maybe you just want to log something. Rather than logging all of these different scattered items on your desk, you can just log the pencil case and see everything that is in there. Now, as we begin to not just group things into objects, but think about how we can organize things into objects, what that does is that mindset shift actually makes us better software engineers. You see, at this point, we're kind of going past just trying to solve problems, but we're also thinking about how we're organizing and tidying our code and making sure that the code we write to solve those problems is easier to manage, easier to read. It's more professional, and we're not just going to thank ourselves for it, but other developers are going to thank us as well. And that's the real power of objects. Now, the most simple, straightforward, and the most common, easiest way that you're going to create an object is with the object list rules, and that is just with these braces there. Now, there is other ways that you can create an object. You can do something like player2 equals new object, and you could also just pass in the properties here. But as you can see, this has less code and looks cleaner. We've seen this before, right? JavaScript gives us a way to create all of the different types with this constructor. You know, we've seen it with strings, we've seen it with numbers, and so on. We can also do this with objects, just as we can with all types. We can use this constructor, but there's no benefit to doing this. So 99% of the time, this is how you're going to be doing it. The most straightforward, easiest way to read. Now, why does JavaScript allow us to create types like this when there's no real benefits? Now, why does JavaScript allow us to even bother creating values like this if there's no real benefit? And it's a lot more straightforward just to assign it to a value. Now, objects have properties and methods, but hang on a minute, don't strings and numbers and booleans allow us to access property and methods as well? Well, yes, they do, but that's strange because they're not technically objects in JavaScript, right? Well, you see, the thing is, one of JavaScript's quirky behaviors is it allows you to treat everything like an object, even if it's not actually an object. And the way it does this is by, up until you use even a primitive, what it's going to do is it's going to do some magic behind the scenes where it's going to wrap that primitive into an object so that you can treat it like an object. So even if we had something like player1, that's a primitive. Well, hang on a minute, how is it we're able to access a method on that value? And there we've just accessed a method on that string. So JavaScript temporarily wraps them in an object behind the scenes when you try to access a property or a method. And that's what makes this feel like it just works. And because of this behavior, it's kind of the reason why JavaScript allows us to create strings, numbers, and booleans using constructor functions like new string or new number. When you do this, you're actually creating them as objects. As you can see, that's an object, even though, yeah, it's a string. Now, some people prefer this approach because it aligns with how they're mentally picturing things. Hey, it acts like an object, I might as well make it one. But honestly, most people don't do this, including me, and you don't need to do this either. It's just one of those quirky behaviors that we accept in JavaScript. We treat primitives like objects, even though they're not, because JavaScript just makes it work under the hood. So yeah, every value can be created using a constructor method. If that helps, if that clicks for you. But if it doesn't, don't worry about it. I don't do it. I don't think I've worked in a code base where anyone creates values using these constructor methods. Now, in JavaScript, objects are mutable. And that's just a fancy way of saying that after we've created an object, we can actually change it. We can update some of its fields. We can add new fields. And we can remove fields as well. Now, this might cause some confusion, especially when you use the const, because a lot of people feel like, oh, well, now it's a constant. You can't change a constant. Well, that only works for primitive types, where for objects, all the constant does is it prevents you from being able to reassign that object. So when you try to reassign an object, as you can see, assignment to constant variable, it's not going to allow you to do that because it's a const. But what we can do is we can go ahead and we can update that variable name. Maybe we want to add another variable like location, or perhaps we want to go ahead and delete a property. All of this is possible with objects in JavaScript. So when working with objects, they don't require predefined fields. I mean, this could even just have been an empty object, right? And then you can go ahead and just add in or update or delete any properties later. This makes working with objects in JavaScript super fast and flexible for development. But just because you can do something, it doesn't mean that you should. Mutating a object like this after it was created can have some undesired side effects and cause issues when trying to use that object later if some of the data looks different than what you was expecting, because you've gone ahead and you've mutated it after it was created, and you can end up introducing bugs. Maybe you try to use a property that was missing, or you was expecting this name to be here, but then for some reason someone else has gone and changed it to something completely different. And this is part of the parcel of JavaScript being a dynamic language. Spaghetti loosey goosey. It's super flexible. We do whatever we want, even when we don't want to, and we shouldn't. Now, one thing noting when it comes to accessing properties on an object, if we attempt to use a property that is not there, JavaScript's not going to complain. It's not going to throw an error and say, it's not going to raise the alarm and say, hey, you've tried to use something and it's not there. Instead, what JavaScript's going to do is it's just going to say unknown, right? That there is no value here. It's absent. So let's say we try to use player help. As you can see, let's just delete that console log so it's a slightly easier. Oh, I've logged the whole player. That is my bad. Player health. As you can see, undefined. So JavaScript allowed us to attempt to access that property, but instead of complaining it was just undefined, there was no value there. This changes, however, when you try to access the property of a property that doesn't exist. So imagine we try to access .health, and then maybe we had a max health, and all of a sudden now JavaScript decides it's going to complain. But this isn't completely random, as frustrating as it might be. The reason for this is because in JavaScript we cannot access properties and methods of values that are undefined or null. So it will throw an error. So at this point, player exists, it's an object. we've tried to access a property on that object, but it doesn't exist, so it just returns undefined. Now when we attempt to use max, however, well, now we're trying to access a property on a value that's undefined, and that's not possible in JavaScript. If we had health and we assign this value as undefined, we're not going to be able to access any properties or methods on this value. It's not an object, and it's also not a primitive like we mentioned previously that JavaScript treats like objects. So you can access properties or methods on any other value in JavaScript: strings, numbers, booleans, objects. But when we attempt to do that on null or undefined, JavaScript is going to complain. Now, and if you want a bit more context on this, you can go back and watch a previous video where we talked about how null and undefined are special types in JavaScript. But yeah, so when we try to access a variable that doesn't exist on health, here we're trying to access a property on a value that's undefined. And as you can see, it can't do it. You cannot read properties of undefined. If this was null, even though null is technically an object in JavaScript, we call it a special type because it doesn't behave like an object, even though the type of is object. Even though the value technically is an object, cannot read properties of null on max. As you can see, the type, where's that button log on? Of course it can't do it because it's throwing an error before it gets there. As you can see, the type is object, but we can't access properties or methods. So this can trip people out because, you know, you access a property, doesn't exist, but it just returns undefined, no biggie. But then when you try to access a property of the non-existing property, well, now it's undefined, and now you're getting an error thrown and you lose your mind. But don't worry, that behavior is expected. Now, if you do want to attempt to use a property that don't exist, what you can do is you can use you can use a safer access with an optional chaining if you don't want JavaScript to throw an error and you still want to get that undefined value. So maybe we've got player.location equals forest. So maybe player has coordinates, and when it has and maybe some players have coordinates and some don't. But if it does have coordinates, maybe I want to access their x coordinate. So let's do that. Player.coordinates.x. Great, the coordinate is 0. But if I was to take this away, and now I'm getting undefined, well, I don't want this behavior. What we can use as a safer access is just like this. So if we are trying to or attempting to access a property on a undefined value, instead of throwing an error, it will still just fall back to being undefined. Needed to save. As you can see, this comes back to that, and then you could use a null is coerce if you wanted this to fall back to a default value. So maybe the default coordinates are 0, and we can do that. Also, when you do declare a variable and you're making that a variable the same name as the property, you can use this destructor in shorthand to make things slightly cleaner. Looks nice, and it also encourages using the same variable names x and x to keep things consistent. Now you can use the safer access, but we can also check if properties exist as well. So maybe we could just do player has coordinates. Let's remove that. Yes, player has coordinates, and if we take them away again, as you can see, we no longer get that message. We could also use another method called the player has own property coordinates if you wanted to check this way. Let's add those back in, and we see that again. Now there is one distinct difference between using has own property and using the in, but that involves us understanding a little bit about the prototype object and inherited values, which we said we wouldn't do. So we're going to skip that for now, but we will cover it in a more advanced video. So we've discussed how to access these properties, delete them and update them. But what if we wanted to access a dynamic variable? What if we didn't know which one we wanted to access in advance? So here we're saying name, but what if this field name was in a variable? Let's call it field equals name. So to access a property dynamically in an object, we can use the square brackets field, and now we can access that property dynamically. Here we get hero, then we can change it to level, change it to level, or inventory. You get the picture, right? If we want to access a property dynamically, we can use that bracket notation. Sometimes when we want to look inside of an object, we can just, print out the entire object. Or sometimes we may need to look inside that object and check each field or value in separately. Same way we may want to iterate over an array, we might find ourselves in a position where we want to loop over an object. This isn't as common, but still we may want to use it. The most direct way to iterate an object is using that for in method, which is going to expose the key. Then we can use that key and pass it in dynamically to access each value in each iteration. And there you have it. We can access the name, health, map, level, inventory. So when we want to be more direct with looping objects, we've got the for in methods. But if you do want to use some of the more traditional iteration methods that are available to arrays, then we first need to take this object and make it iterable so that we can use those array methods. So maybe if you want the keys, you could use object.keys to take all of the keys in this object and break them out into an array. And we can do the same thing with values. And if you maybe wanted the key and the value, you could use entries. Look, Cursor AI knows exactly what I want to do today, if we don't mind. And we can break those out and to get the keys and the values there. So there's just a few ways we can iterate over an object. Just to recap, the most direct way of iterating an object is using the for in method. The for of method and other traditional array iteration methods won't work on an object. So if you do want to do that, you first need to make them iterable by either taking the keys, the values, or using entries to get the key and value and breaking them out into arrays. The final thing about objects that you want to understand to really grasp objects at a fundamental level is understanding is not just being able to clone an object. That's pretty straightforward. But what you want to know is, why do we clone objects? We wouldn't clone a primitive, we wouldn't clone a string, we wouldn't clone a number. So why would we want to clone an object? And that is because objects are reference types. So if I wanted to clone a string, for example, I may have player name equals hero. And then if I wanted a duplicate value of player name, that's pretty straightforward. I could just create player name 2 and I could assign it to player name. And just like that, on line 3, I've copied the value in player name in player 2, right? And when we log those out, they've each got their own player name. If I decided later on that I wanted to change player name, no biggie, I can change that player name. Doesn't impact player 2 because player 2 has its own copy of that value. Same thing if I was to, change player 2, it's not gonna change the original name because it has its own value. Now things change when we begin to use objects, right? When we assign one object to another, JavaScript doesn't create a copy of that value. Instead, it shares the reference. So let's just take a look at what that looks like. So we have player here, name, all looks good. And then we decide to create a player 2 and we assign it to player. Now let's log both of those out. Let's call it player 1. I like how that looks. So player 1 equals player 2. Then we log the, what have I done? What have I done? There we go, typo. Okay. So as you can see, we have player 1 and player 2 with the exact same values. But there is only one value. There is currently only one object, right? What do I mean by that? Well, let's say I made a change to player 1. Okay, I've only changed player 1, right? Now when we did this with those strings, the second variable never changed. But let's see what happens when we do the same thing with objects. So here we've got the name, Bruce Wayne, but if you look at player 2, player 2's name also changed even though we only changed it on player 1. And that is because objects are reference types. When we assign an object to another object, we don't copy their values. Instead, they share the same values in the memory. A good way to understand this is with a visual representation. So let's say we had a string and it's called player1. This variable represents our container. It's going to contain maybe the value player1. Then if we was to create another, let's just make this easier to spin. So if I was to go player name, I call it player1. So let's just demonstrate that down here. Player name equals player1. Then if on the line below I decided to create another player, player name 2 equals player name. Primitives have their own values, right? So when on line 21, when we assigned player name 2 to player name on line 19, we created another variable, another container. We didn't, and let's give this a variable name, player name 2, did we call it? Now on line 21, when we assigned player name 2 to player name, what happened was we created a clone of this value, and this now has its own value. Primitives store a copy of their own values. This behavior though is different when we look at objects. So let's now create another variable that represents an object, and this was called player1. And let's go ahead and just copy these values into here. And this is going to represent line 1 when we created that object. Now objects store references, not values. Objects are reference types. So instead of storing this value in this variable container, instead it stores a reference. Now when we created player 2 on line 10, we have another variable. This variable is called player 2. Now we didn't get a copy of this value. Instead we got a copy of its reference to the value. We got what was inside of the variable, the container, which is just a reference. So if this primitive copied a value, this reference type just got a reference to that same value. So now both of these values share the same reference to this value here. And that is why when we changed player name 1 to, what did we change it to, Bruce Wayne, it also changed for player 2 because they point to the same value, right? They don't get a copy of their own value, they're still sharing the same one. And same thing if we was to change something for player 2. Let's change the level, let's level them up to level 100. As you'll see, it's also going to change it for player 1, right? We changed level to 100, but it changed here because when we changed it to player 2, player 1 still points to that same value. Now when we want to reuse objects, copy objects, extend them, this is why it's super important in JavaScript to actually clone them, because if we just assign one variable to another, we're copying the reference. So when we want to copy an actual value, it's important that we clone it. We actually tell JavaScript, I don't want a reference, I want to copy the whole value. Now the most modern and clean way to do this is within spread syntax. So here player 2 equals player 1. We didn't just say to JavaScript I want a reference of player 1, I actually want to copy all of its values. So now it's got its own copy. Now hopefully this time when player 1 is changed to Bruce Wayne, it's not also changed for player 2. But player 2 is now still hero, player 1 is now Bruce Wayne. Player 2 level 100, but player 1 remains 1, because now we've cloned the value and got a copy of all of those fields and values, not just a reference. And that is why cloning objects in JavaScript is important, because they're reference types. Okay guys, we covered a lot on objects, and that was just the basics and fundamentals. Hopefully by now you kind of understand why we didn't want to dive into all those advanced concepts. there's only so much we can digest at one time. So let's just digest the fundamentals and the basics we need just to get started with objects, get confident with objects, get more experience with objects. And the more we use them, the more a lot of their behaviors are ingrained into our subconscious. And then that's going to give us room to think about those more advanced concepts and tackle them. None of these advanced stuff should be coming up in job interviews. If you're fresh out of like a coding camp, for example, you're not going to be expected to understand the prototype chain or prototypal inheritance or property descriptors. And if they was to come up in a job interview, honestly, I wouldn't want that job anyway, because too much is being asked for you, right? You're just getting started, so you don't need to know these advanced topics, and it shouldn't be expected of you either. So if someone is asking you those questions at a junior level, do you even want that job, or is it a red flag, or is the interviewer just showing off, asking you a bunch of questions to which he has the answers in front of his screen? So yeah, just to recap, we learned about what objects are, why we use them, how they improve our code base, how they make us better developers. Then we talked about how everything in JavaScript is actually an object and how things work under the hood. That will definitely get you some bonus points at this level, because a lot of people don't really think that JavaScript's at that level, right? They have a string and they just start using methods and properties without challenging or thinking, hey, hang on a minute, this isn't an object, how come I can do this? So that's pretty cool, if you can nail that down. We did a bunch of stuff with properties and checking for properties, but really, look, all that stuff will come. You're not really going to master all that stuff in this video. That's just something you got to get more hands-on experience with. So the more you're thinking about objects, grouping things into objects, using objects, the more experience you're getting with objects. And that's really what I want you to take from this video. Then we looked at iterating objects. Look, we've kind of breezed over that because look, you can ask ChatGPT that question, right? Then we talked about cloning objects and why we want to do that. That's something you should really understand. Even at a junior level, understanding objects are reference types and understanding what this means when we assign one object to another. So you don't get surprised by the behavior when you change the target object and it also impacts the source, or you change the source object and you change the target. That's something that could definitely come up in an interview at this level, even fresh out of a boot camp, because it is something that you need to know before going into a production code base, because you could accidentally introduce some bugs if you don't understand that behavior properly. That's enough from me. This video has been long enough. I hope you got some value from it. If you did, please like it. It helps the algorithm. And yeah, if you like this content, if you like me breaking down everything that you need to know in JavaScript at each level, and you want to stay on this journey as we progress through onto the harder belt, then please make sure you are subscribed so you don't miss the next video. See you in the next one.